A common task in our glaze making processes is the creation of a similar glaze to one we've picked up from a magazine or other overseas source. The task is to make a glaze with a similar unity formula to the foreign glaze. Such a glaze should fire with qualities close to the original. As an example, we'll use Reader's Digest Red, which was entered from the internet and saved in a previous tutorial. Let's start by booting Matrix. Then we'll load the recipe, which should be saved in our Matrix folder. Yes, there it is there. The aim in this tutorial is to make another glaze with a near to identical unity formula using materials that we have. This button creates a copy of the glaze in the R1 panel and puts it into the R2 panel. In order to see the recipe's copy, we'll need to click this arrow, which will expand the matrix window. We will make our changes in the R1 panel, which is active at the moment. As we make changes to the recipe, Matrix will generate a new unity formula, which will appear in the R1 formula column. Changes can be observed graphically on the limits graph. Here we are, we can open the limits graph and we'll pop it over there where we can keep an eye on it. At the moment, the limits graph shows both the original and the copy. The original is marked with yellow rectangles and the copy is marked with red spots, and of course they are sitting on top of one another at the moment. Looking at the recipe, I can see that I will need to change the NCE4 feldspar, the flint, and the EPK kaolin. Before selecting a replacement feldspar, we should check to see if NCE4 is a soda spar or a potash spar. We can open a window that displays the unity formula for a material in the recipe. We highlight the material and we click this button here. The information window for the feldspar shows that NCE4 is a soda spar. That is, it has a dominance of sodium oxide. Now I need to open the materials list window. Locating a soda spar is easy. We can click the Display Matte Formula button and the window expands to show you the unity formula for the highlighted material in the materials list. Let's have a look at feldspars that I have. I'll just scroll down here. There is one that I have. It is a soda spar. Yes, a dominance of sodium oxide. So I'll use that material. Double click on the material and it replaces the feldspar that was in the recipe originally. Next we will choose a replacement for the EPK. This is a china clay, so I will choose a china clay locally available. There's one there. Finally, I will replace flint with silica. They are essentially the same material, but in New Zealand we call flint silica. We can now, just a minute, we'll find the silica. There it is. Now we can close the window. Changing the materials in the recipe has changed the unity formula. This is because the replacement materials had a different chemical composition to the originals. Now we must change the recipe's quantities to try and restore the original unity formula in the copy. Changing the quantity of a material in a recipe is best done using the increments recipe quantities window. This window allows us to click arrows which will change the quantity of a highlighted material. The amount of change, the increment, is adjustable. The arrow buttons, minus or plus, are clicked as needed. From the limits graph and the formula columns, we can see that the nepheline cyanide is providing too much KNO. In glaze chemistry, we should always start with the most complex material. The primary source of KNO in this recipe is the nepheline cyanide. In this case, we want to bring the KNO back to that of the original. So we'll highlight this material. It's already highlighted. We should decrease the quantity of the nepheline cyanide until the KNO comes into line with the original. So we'll keep clicking the minus button until the numbers in the copy are approximately the same as those in the original. That's about it. Proportions of magnesium and calcium are near enough so the flux group of oxides looks okay. Now we should turn our attention to the alumina and the silica. Increasing the quantity of New Zealand china clay a little will bring the alumina into line. Increasing the quantity of silica will bring the silica into line. We could make fine adjustments to the unity formula of the copy by lowering the increment value, but I think the new recipe is close enough. The last job to do would be to make the recipe total 100. We can do this by clicking this % button. A window appears asking if we want to include the colorant. In this case, the proportion of red iron oxide should remain the same, so we will click the No button. In summary, this is what we have done. We made a copy of the original recipe and then selected materials we have to replace those that we don't have. When those were changed, the original quantities of those materials changed the unity formula, so we proceeded to adjust the recipe's quantities while focusing on the unity formula. Making these changes resulted in our copy not totaling 100, so our final act was to convert the recipe to total 100. All that remains is to save the new recipe and test fire it. Will its fired quality be identical to the original? Well, without firing the original, we won't be able to tell, but it will be near enough. When we have a fired sample of the new recipe, we may want to make some further adjustments to achieve a quality that we like. Let's save this recipe that we've changed. We'll call it Red Digest Copy, and we'll click the Save button here. Red Digest Copy, Save. And the task is done.